well, whatever degrees it is. Okay, so there was a problem like this one, a little bit, kind of, but where you're pushing on an object, pushing or pulling. So if we look at all the forces on here, on this object, we have the mass, we have the Fn is what? Normal force. And since we're on a horizontal surface, it is equal to the weight. They're equal to each other. We're pulling, or we could have a pushing force. We have x, and then we split it into a component of x, f of y. And so that would be our force diagram. We're using all of the same equations basically. I just put in some specifics like the force applied. Made it force pull. You can make it force applied, doesn't matter. But we're just basically going to be using your trig functions. Force of the pull in the y direction. Yeah. Yep. Okay, then we look at the net forces in the y direction when we look at that picture. Our y directional forces, we have normal forces up, and we're going to add the y force here, and then we'll subtract the weight. So that's what this is. We have the normal force, we subtract the weight, which is mg, add f of y, and if we're not accelerating in that direction, it's going to equal 0. Usually we're not accelerating in the vertical direction, so that will always equal 0. The normal force, I misspoke before. The normal force, since we're not pulling horizontal to the ground, it's not equal to the weight. It's equal to weight minus normal or the y force. Normal force is kind of like the apparent weight, just like when we were in the problems we did with the elevator. When we went down, we felt like we were lighter. If you're pulling up at a certain angle, it's actually going to make that box or whatever feel a little lighter, kind of apparent weight. That's the normal force. And then the x forces, all we have is the f of x and the x direction, and that is equal to ma. And I put max just because we're accelerating the x direction, so you can keep that straight. So if we want to do a problem like this, James exerts a force of 72 newtons along the handle of a lawnmower to push it across the lawn. Find the horizontal component of the force when the handle is at an angle with the lawn of 60 degrees. Basically, kind of like what we were doing yesterday. Well, that's not very straight. So for pushing a lawnmower, we're pushing, so we're going down at this angle. This angle is 60. And this is 72 newtons. Yeah. It'd be like you're pushing down and the handle is, yeah. At same angle, yeah. So we would use, if we're going to find f of x, should have made a new page. Adjacent over hypotenuse is equal to cosine of 60, right? So 72 times the cosine of 60. So f of x is equal to 36 newtons. Then if we knew the mass of the lawnmower, we could find the acceleration of the lawnmower. It'd be 36 is equal to ma. If we wanted to find that. I don't know, maybe that's what the next problem does. I don't remember. Nope. Okay, a 30 kilogram box is being pulled with a 52 Newton force at a 20-degree angle to the frictionless surface. What is the normal force and the acceleration? 30, 52, 20. And right, that's the information they give you. 30 or 32? 30. Oh. I just remembered it wrong. 30. Okay. So first it asks for the normal force. So here's normal force. We have the weight, and then we have f of x, and we have f of y. So normal force is in what direction? Which is on which axis? The y. So we want to find the sum of the y forces. So what are the sum of the forces in the y direction? Not using numbers, using our symbols. What do we have? We have the normal force plus f of y minus the weight, right? That equals ma, but are we accelerating in the y direction? Are we accelerating vertically? No. So then a is 0, so oops, it all equals 0. So then the normal force will equal to the weight minus f of y. Because the question asks for the normal force. Are we able to find, we'd be able to find f of y, right?
Isn't f of n equal to w though?
Not when you're pulling at an angle. That's only if you're pulling horizontally. Nope. And then just, you can do the bonus on the back. So right, if it wouldn't, last chapter we were pulling horizontally to the ground, so it's equal. Since we're pulling at an angle, they're not going to be equal. Because if we were pulling horizontally, would there be any f of y? No. So we wouldn't have to include that in our y forces. So our normal force is equal to W is mg, so we have 30 times 9.8. Okay, I'm going to put that number in there. 294. Then f of y, $17.8. So that minus 17.8 newtons. So our normal force is 276.2 newtons. Do you guys have a question on that? Does that make sense for normal force? Why don't I add them?
No, because when he's going down,
Right. Right. We add the f of y because it's going up right here, and we subtract w.
And you subtract.
W because it's going down. Right. And then we would add w on this side and subtract f of y to get it on the other side. Up we just make as positive, down negative. So really you're adding a negative, but we just put subtract. Then I think the other part of the question asks for the acceleration, doesn't it? So acceleration, that's in the x direction. What are our forces in the x direction? F of x, and that's
Please
it.
dismiss the junior high girls basketball team from class at this time. Junior high girls basketball teams need to be dismissed from class.
And that, are we accelerating in the x direction? Yes, so we're going to have that equal to be ma x, just so that we know we're accelerating in the x direction. What does f of x equal then? 48.9. So we have, oops. So we have 48.9, yep, equals 30 times ax. So we would divide. So our acceleration in the x direction is 1 point something. 1.6 meters per second squared. Questions on that? Okay. A force is a vector. A force is a vector, though. Yeah, because you would take this, which direction are these pulling, like that?
I guess it just says there's a force. It doesn't say if they're pulling or anything. It just says acting. So it could be both pushing. One could be pushing, one could be
You could
pulling.
make it whatever you want, then that'd be fine. How'd you do it? Did you add them together, or did you subtract them, or?
I subtracted those two.
So you took F1 minus that?
Yeah, which gave me 17.2.
Okay, so you're assuming that it's like this, which means these are like that. And then you took 27 minus 20. So it had to be that direction.
Yeah, going up.
Mm-hmm.
So
So
you
that,
apply.
right, that way. Okay, the 72 kilogram sled is accelerating at 3.3 meters per second squared while being pulled with a force of 15 degrees. What's the magnitude of the force? So this one where they're giving the acceleration, we're going to have to find that vector. Mm-hmm. Yep. So 15 degrees, right? This is what we're looking for right here. 72 kilograms or 72 newtons? Okay.
So when we find F equals ma, it has to be x, or the f of x.
Right. So we have f of x is equal to max. So that's how we're going to find f of x. So we'd have 72 kilograms times the 3.3. $200 and what? Do you agree? Okay. So now we have f of x, 237.6. Yep, we know the angle, so then we can find x. You said it was what? 0.98. So there we go. How about you guys do this one? At least get a start, and then I'll catch up to you.
It's just an angle moving straight that way. That's the only direction that forces can go.
Yep, there's no y.
Okay, so we have next.
Some extensions even farther you can go is like after 2 seconds, how fast is it going? And then you have to use one of those 4 acceleration equations. Or how far does it go? Or those. Is it 25 Newton force? Yeah. Normal force and acceleration. Those sketchbooks are a lot of work for one a week.
It's like everybody's, lots of people are done with their paintings, and I'm barely starting.
Do some people not pick very hard sketchbook things, or?
Like this year, I'm putting my time into it. It's actually my portfolio.
What's your portfolio?
For college admissions, scholarships.
Oh. So to find normal force, we're going to take all of our forces in the y direction. Now this time, because we're pushing, F of y is down. So we're going to have the normal force minus the weight minus our y force, because it's going down. We're not accelerating that direction, so we have y. So our normal force is actually equal to the weight plus our y force. I didn't calculate. 5 times the sine of 40.5. So did you get 17.2? $147. So 164.2 for the total normal force. Yep. There we go. And then they ask for the acceleration, so we're accelerating in the x direction. So all we have is f of x. What do you think we would add in there? We're going to add something so that we'll have another force in the x direction. What do you think we'll add eventually? Friction, yeah. So what do we have? 25 times the cosine. 18.1 is f of x. 18.1. Well, the mass is 15. And so we can find a of x. So 1.2.
Where'd you get 18.1 from?
That's f of x.
Oh. Did you get using that for
No, f of x isn't your normal force.
so what's
F of x is right here. And then this is f of y.
actually this probably will be the same. You're finding acceleration. So your acceleration is f of x times f of x equals
MA?
mass times distance.
Yes. And then you divide it by the mass?
So we are just finding it.
No, how I found f of x was I had f of x over 25 is equal to the cosine of 43.5.
Why you find your normal force then?
It just asked for it.
But if they don't ask for it, you just want acceleration to do it.
Right. If they just ask for acceleration, you don't have to find normal force. The reason why we're learning how to do normal force, because when we go to find friction, we need normal force, because friction is equal to mu times normal force. So we have to learn how we're going to solve for normal force.
So all you need to remember from normal force is f of y plus movement.
Yeah. Normal force we make up as positive. So since normal force is up, it's positive. We add a negative weight because weight's down. And then for this one, we're adding a negative y because y is down since we're pushing. For pulling, y is up, so we would add y. And we'll talk about friction. We won't do all the problems for it. We'll finish some of the problems up on Monday. So here, same exact situation, but we're going to add friction in. And just remember that friction is opposite the direction of movement. So since f of x, it's going to be opposite f of x. Since f of x is to the right, friction is to the left. So they're always going to be opposite each other. Otherwise, everything else stays the same. And our f of y equations are going to stay the same. The f of x is just going to change because we're going to have f of x. The sum of the forces in the x direction is be f of x minus f of f equals max. That's the only thing that's really going to change. Okay. Now sometimes if you're like pushing x or pushing down, x will be to the left, so then friction will be to the right. It shouldn't really matter that way. They're just opposite. So let's do at least one of these. Oh, let me go back. Okay. So 95 kilogram chair is being pulled along a carpeted floor at a constant velocity. Constant velocity, what does that tell you? And are we accelerating? No, so acceleration is 0 since we're going to accelerate at constant velocity. The frictional force is 53 newtons. What's the pulling force if it's being applied at 44.8 degrees to the floor? What? Ah, yes. F of x is equal to the frictional force. We'll draw a picture to show that. Okay, how big is our chair? 92 kilograms, is that? 95. And it's being pushed, correct, or is it pulled? Pulled. And what's the angle? And we know friction is equal to 0.83. The force of friction was that small? Oh. Wait, I think, just a second. I think what I have on my, change it, oh shoot. Change it so it looks like what mine, I think I remember this. Change it so it looks like mine. 95 kilogram chair, it tells you the frictional force is 53 newtons. And then the angle. Coefficient of friction, remember, is mu, so if we ever do see that. Yeah, we'll do those. So we have 53 newtons here. So, but our acceleration is 0 since we're going at a constant velocity. So our f of x, our force, because it's asking for f of x, right? Or what does it ask for?
F of n.
Oh, what's the normal force? No, what's the pulling force? So it's looking for this right here. Yes. So we can find f of x, because we know f of x minus f of f is equal to max, correct? Yeah. This is 0, though, because acceleration is 0. So that means that our f of x is equal to f of f. And that is equal to, then, 53 newtons. Yeah, I changed that, so that should be 53 newtons for friction. 53. Okay. So we have 53 divided by the cosine of 44.8. $74.7. There we go. Let me look and see. Right, and then I added this other, what's f of n? Well, you would just use this.
Use f of y
Mm-hmm. So we have the sum of the forces in the y direction is equal to, with the normal force minus the weight plus f of y. And that equals 0. So what's our weight? 95 times 9.8? 931. So 931 minus Fy is 52.6. So we get then 878.4. That's newtons. And now, just for kicks and giggles, what would mu equal then? Because f of s is equal to mu times the normal force. That's our equation for friction right here. Erase this. And so 0.06. We take 53. Yep. There you go. So on the board over there, there's a little assignment, the page 865, 1, 2, 5, 6, 7, 7, or 10, 11. Work on that. We'll finish the problems on the friction on Monday, and then those problems we do at the end of the period on Monday. So I don't know how much time we'll have. How many problems are there actually left that we would have to do? Oh, there's only one more. So maybe we'll do friction and equilibrium. Do a few notes, and then the problems we do at the end of the period. Or if